Where'd it go? I don't know where it went, but let me rewrite it. It was cosecant theta.
Sine theta, cot theta.
Okay. So what is cosecant theta equivalent to?
1 over sine theta
Yes, good.
times, or should I leave sine theta?
Yeah, times.
Should I simplify it? Okay.
Yeah, so yeah, what's the first simplification that you can do?
Oh, here. So it's 1 over tan theta,
Mm-hmm.
which is cot theta.
Right, and that was the goal for it to equal in the end.
Okay.
Okay, so let's do one more.
I see.
And that's what that's supposed to equal to in the end, right? Or you simplified it. Okay, so let's try a more challenging one. So we've got here, what is it? Going to number 10.
Sine squared theta, sec theta, cosecant theta, sorry.
Okay.
I forgot what sine squared theta is.
So at that moment, just even keep that. The first thing always is the inverse functions to like retranslate them.
Should I just keep sine?
So, or maybe if it helps you with these guys, write it like sine theta times sine theta.
Oh, okay.
So then we can see that this can actually cancel with this.
Oh, right.
And what we're left with in the end is just
And then it's tan.
sine exactly equals tan theta. And they become so simple. See, this is where I actually started to find these really fun to work out.
Oh, and then there was this last one.
Okay, let's try that one.
Get tan theta, cosecant squared theta.
Tan theta cosecant squared theta.
Over 1 plus tan squared theta.
Okay. So let's see. I'll give you a hint. First, just work out simplifying that numerator, like independently.
Yeah. I'm not really sure.
So, right. When we see tan theta, let's write it as sine theta.
Over cosine.
Right, over cosine theta, and then we put that there. So now, yeah. So now this is really cosine theta, sine theta. In the top.
Mm-hmm.
And now we've got 1 plus tan squared theta. Okay, so first of all, if I divide all of these,
Wait, isn't this under 1?
oh, it is. Okay, we'll fix that in a moment, though. We're just going to say in the end that this equals 1 over cosine theta, sine theta. And that's it. We're going to use this for that. But now I'm working on the bottom part. So if I'm dividing both sides by sine squared x, oops, I'm going to flip it the other way. Cosine squared x. This here is the same as tan squared x plus 1 equals secant squared x.
Okay.
So tan squared theta plus 1 is the same as secant squared theta.
Okay.
So we're going to put this all, which is the same as 1 over cosine x, cosine x.
Wait, is that just like a rule, or is that?
Yes, it's a derivation off the original identity of sine squared x plus cosine squared x equals 1. From this original formula, you can either divide by sine squared x or by cosine squared x, and you get 2 extra identities. So when we divide by cosine squared x, we get 1 plus tan squared x equals secant squared x. When we divide by sine squared x, we get 1 plus cotangent squared x equals cosecant squared x. Okay, and I mean, you can just do the math out how I did it here, but that's how it is in the end. Okay, so in the end, what we've come to the conclusion is, first of all, we know that tan theta cosecant squared theta is equivalent to 1 over cosine theta sine theta. And 1 plus tan squared theta is equal to 1 over cosine theta, cosine theta. So we're dividing these two. So it's keep, change to multiplication, and take the reciprocal of this fraction. So and we get to this. Mm-hmm. So that's what we get when I'm dividing this term by that term. And now here we go. Cosine theta and cosine theta cancel. So this equals cosine theta over sine theta, which equals cotangent theta. And that's the final very elegant simplification to what was this here.